Hello everyone, welcome to my channel on data analytics. I am your host Professor Rage Uday Kiran. In this video, we are going to cover the topic on creating utility databases. The outline of my presentation will be as follows. First, I will discuss the limitations of transactional and temporal databases. Next, I will be describing you what is a utility database. Then, I talk about different types of utility databases that are available. Next, I discuss the rules to be followed by the users to create a utility database. Then, I provide some real world examples on how to create utility datasets. Finally, I give a small demo on creating utility databases. Coming to the topic on limitations of transactional and temporal databases. Basically, transactional and temporal databases are binary databases. It means they only capture the occurrence or non-occurrence of a item in a transaction. They only capture the data and they completely disregard the metadata of a transaction. If you are not familiar with transactional and temporal databases, I request the viewers to check the links shown above. So, to address the limitations, we have come up with the utility databases. Utility databases try to address the fundamental limitations of transactional and temporal databases. So, utility databases are nothing but non-binary representations of transactional or temporal databases. So we have to keep in mind that utility is a generic term. It can mean any measure, price, amount, distance, cost, anything can come. Body temperature, everything is a utility function. And then in utility database, there will be columnar separators. There will be 3 columns and each column is separated using a fixed separator called colon. Coming to the types of utility databases, as we have discussed, transactional databases and temporal databases are binary transactional databases, whereas utility is a non-binary database. So when we perform a join across these 3 types of databases, the resultant will be the following 2 types. One is utility transactional database, then utility temporal database as shown here. So in utility transactional database, we have the transactional database followed as one column, the total utility in the another column and the individual utilities of the items. So total utility is nothing but the sum of individual utilities of the items. And when it comes to utility temporal database, please take note that we add additional information, that is timestamp, to the row. So that is the difference between utility transactional database and utility temporal database. Now, if if we are asked to create a utility database, how do we create it? What are the rules we have to follow to create a utility database? So let us look at them. The first one, utility database contains 3 columns. So here you can see we have created 3 columns, column 1, column 2 and column 3. Each column is separated by a colon mark. The first column must always represent data. You cannot change the columns. Okay, please keep that in mind. So the first column must always represent data. The second column always represent total utility value. The third column represents the individual utility values of the items. So this way the three columns have to be structured. We cannot change the order of these columns. Okay, so the order of the columns should not be changed. Similarly, the order of elements within the columns is also preserved. For example, if we look here, bread occurred before jam in column 1. So when we look at the individual utilities of the items, the value in the first value in the third column represents the utility of the bread, that is the price the person has paid. Similarly, the second utility value in the third column corresponds to the item jam. So this way the order of the occurrences of items in a column is preserved across the columns also. Now, now let us look at how do we create a utility database. For this we use two data sets. One is sales data and another one is multiple sensors data. Now coming to the sales data, assume there is a supermarket selling the items bread, jam, butter at different prices. Now, a customer at a timestamp 1 has visited the supermarket and he purchased one packet of bread, two jars of jam. Then, for each item, he paid $1 for bread, $6 for jam, and then total amount he paid is 7. So he paid that amount. This is the first transaction of a customer. Next, another visitor came to the supermarket at the timestamp 3 and purchased some items. Similarly, many customers have come at different timestamps and purchased whatever the items they are in need of and paid the amount. In this transactional data or in this sales data of the customers, there is data and metadata. Transactional databases and temporal databases only capture data. However, utility databases capture both data and also metadata. So when we convert this sales data into transactional database, the first column represents items, the second column represents uh, amount, the third column represents the prices. So we can say that in the first row, that is the first customer came to the supermarket, bought bread and jam. The individual utilities or the individual prices of these items is 1 and 6 respectively. And then the total price paid by him is $7. So like this we create utility transactional database. If the users want to create a utility temporal database, then they simply have to add the timestamp at each row. Please remember that timestamp and items are not treated as separate columns. So there is no need to add a colon to separate them. Simply use any separator. So this is how we create utility transactional database and utility temporal databases. Now let us see how we create utility databases if we are collecting data from multiple sensor data. So we are taking the air pollution data generated by a sensor network set up by the Ministry of Environment, Japan. So the red points on this figure represent the locations where sensors are collecting the pollution levels. So every hour this network is generating the is capturing the amount of pollution that is being captured. For example, if you see the first two columns represent the timestamp, that is at a particular day, at a particular hour, how much value of pollution, say PM 2.5, was recorded by every sensor. So this kind of data is being generated at each hour how much PM 2.5 or any other pollutant is being recorded by a particular sensor. This data we can simply convert it into a utility database in a very simple format. So we simply say S1, S2, S3, so on up to Sn. So these are all the sensors, colon. Then we sum up all the values of these sensors and we write it here as a total utility value. And then in the third column, using colon, we say the individual pollution values recorded by the sensors. It means 60, 60, so on up to 67. This way, we create the utility databases. Now, let us look at a small demo on how to create a utility database. For demonstration purposes, let us take an example. Let us supermarket example and let us try to create it by hand. So I am opening the terminal. So in the terminal, I am creating sales utility database.txt. So assume the first customer came to my supermarket. He purchased bread, jam, butter. So I will mention the utility value later. Let us say the bread value is 1. Jam, he spent $10, and for butter he has spent $12. So the total revenue and from this data is 10 plus 12, that is 22, 22 plus 1, 23. So 23 is the total utility value. Please do not use any space before the colons. Next, let us say the other person came, he purchased jam, bat, ball, cheese. Then let jam he spent $10, bat he spent $25, ball he spent $5, for cheese he spent $8. Then total amount he spent for this purchase is 10 plus 15, 25, 25 plus 5, 30, 30 plus 8, 38. So in this way we create the utility database. Once we create this utility database, we input it to a pattern mining algorithm, say utility mining algorithm, and we extract the patterns that have high value. Very simple. So thank you very much for listening to our video and talk. If you liked our work, please press the like button and subscribe to our channel for interesting information and updates. Thank you.